The Moody's Mega Math Challenge gives teams of 11th and 12th graders the opportunity to tackle a real-world problem while working under time and resource constraints, much like those faced by industrial applied mathematicians. Problems used for the M3 Challenge must be realistic modeling problems that can be studied, solved, and documented in 14 hours by high school students, using only internet resources and publicly available reference materials.
We painstakingly think about what would make a good question. So on the one hand, we want something for which there's data available that the students can find on the internet, but on the other hand, we don't want there to be too much information in that we don't want to pick a problem that's already been solved.
This year's M3 Challenge asked participants to come up with a way to quantify the plastic waste filling our nation's landfills, and to suggest the best recycling methods for U.S. cities to implement based on mathematically modeling the relevant variables. They were then to use that model as a basis for recommending nationwide recycling standards.
This year has been designated as the Mathematics of Planet Earth year. So there's more focus in the math community on, I think, sustainability problems, on real-world mathematics. And this problem, it's a subject that I think a lot of students and people in general are familiar with.
This year's problem was actually inspired by the North Pacific garbage patch. I was in shock when I learned about this, and I just kept thinking, wow, more people need to know about this situation and make them start thinking about the one-use plastic that they're taking into their lives.
The question was, once we have this information, how do we use it to make a helpful recommendation to governments to best promote recycling at a minimal cost? The amount of recyclable materials that are going to end up in landfills is greater than all the landfill capacity in North Carolina already. So just realizing that, that's something that really hits you, and it makes you realize how much we need to go ahead and tackle these problems right now.
All of these teams were able to take some data and come up with these amazing predictions. And that was through the use of some modeling, through the use of some applied math. So I think it shows that even at a high school level, applied math can help solve a real-world problem.
To keep the students interested in math, I think they're lost at a very early age. If you can show them, I would say even in elementary school, that they can get solutions to problems that are interesting to them and relevant, that they'll stick with it because they can see what can be accomplished with it.